How are you, class? Welcome back to our lesson today, physics, Form 1, and the topic is pressure. And today we are going to look at a subtopic of pressure in liquids or pressure in fluids. Now, last time, briefly, we looked at the pressure in solids, and there are two factors that we found out that determine the pressure in solids. And one of them was the area on which the pressure is exerted, and the other one was the force that exerts on the area. Now today, pressure in fluids or pressure in liquids, we are also going to look at what factors determine the pressure in liquids or in fluids, and we are going to give briefly a demonstration. We look at how the pressure will be determined. So we have a bottle which has 3 holes. You have 3 holes. A is at the bottom, B at the center, and C at the top. And I want to fill this bottle with some water, and we look at how far the water will be thrown. So looking at the way the water is thrown, you can see that the lower one throws water very far away. The second one throws water next, and the upper one throws water the closest, just closer to the bottle. This is a demonstration that is telling us that pressure here, because we have a bigger depth at the lower hole, then the pressure at the lower hole is much greater than the pressure at the upper hole, because the hole at the bottom throws water very far away, and then the hole at the top throws water just closer to the bottle. And this is a demonstration that shows that one of the factors that affect pressure in liquids is the depth. Now, looking at what we have on the screen again, we can see that this is a similar figure to what we have demonstrated. If we look at the hole at the bottom throws water very far away at a distance Z. The hole at the middle is throwing water not very far away, but at a distance Y. The top hole is throwing water the closest distance X. And therefore, from this particular demonstration, what do we exactly conclude? What exactly do we get from there? Now, our conclusion, as we can see, is that pressure of water or pressure of a liquid at the hole A is greater than the pressure at the hole B. And the pressure at B is also greater than the pressure at the hole C, the hole at the top. Hence, from this, we can see that pressure is increasing with depth. From the top, the pressure will be increasing with that depth. The reason is because the hole at the bottom is having a bigger mass of the water, and therefore a lot of the water is pressing downwards to the lower hole, and therefore that lower hole will have a very high pressure pushing the water to a very far distance. So increase in pressure with depth explains why sometimes you have a dam constructed with a thicker wall at the bottom. The pressure at the bottom of a dam, because you have a greater mass of water, at the bottom we have more pressure. So therefore, the wall at the bottom must be constructed to be very much thick to withstand that high pressure. So, apart from the depth, we have other factors that determine the pressure in liquids. And we can look at them. The first factor that determines pressure in liquids, as we have said, is the depth. Sometimes we call it the height. The height through which the fluid is taking. And the more the depth h, the more the pressure. The other factor that determines pressure in liquids or pressure in fluids is the density of that liquid. The density of that liquid. If we had put another liquid which has another density here, for example, if we take a liquid which has a higher density than this, then we are going to realize that the distance through which the water is going to be thrown will be different from the distance that this water here has thrown at that particular distance. So pressure also increases with density. The higher the density, the more the pressure. So if the liquid we put into that bottle, another liquid, has a higher density than the density we have for that liquid which we already have there, then we realize that the distance through which the liquid will be thrown will be much bigger than the distance that we have, because pressure increases with the density. And then another factor that determines pressure in liquids is the gravitational pull. The gravitational pull downwards. On Earth, the gravitational pull is constant, but we know that the gravitational pull changes if we go to another planet. So if that gravitational pull changes, then the pressure will also change depending on that gravitational pull. If the gravitational pull is higher, we obviously have pressure that will also be very high. So pressure will also increase with the gravitational pull, G. And looking at these three factors, these are the factors that determine the pressure in liquid, the pressure in fluids. Now, how do we get the pressure formula in liquids? The formula that determines pressure, or the formula that you can use to calculate the pressure in fluids. And this is how we determine it. Consider that we have a container, a cuboid container, a container that looks like this. Suppose the liquid occupies that height, h, and at the bottom of the container we have an area A. So the container is exerting an area A, or the liquid inside is actually exerting downwards at an area A. If that liquid has a weight W, then we realize that pressure pressure will be given by weight divided by the area, where the weight is representing the force, because we know pressure is equal to force over area. So therefore, the weight of that liquid inside the container will be the force exerting on that area, and therefore we can calculate, we can take that weight to be the force on which the area is being exerted. And so, if that is the case, how can we break the weight? Weight is broken by taking, or by being equal to mass times G. Weight is equal to mass times G. And how do we break the mass? Mass is also equal, we know density is equal to mass over volume, so therefore mass will be equal to the density multiplied by the volume. Alright? And again, how do we break the volume? The volume is broken by taking the area at the bottom multiplying by the height. The volume of that liquid will therefore be the area at the bottom multiplied by the height. Volume multiplied by the height. So if we combine all these factors to the weight, then the weight will be given by putting all these factors there. The mass is equal to density times V, and V is